Welcome to our first mathematics online class. Today, our lesson is all about interior angles of a triangle. You have learned already the 6 classifications of triangle. 3 are based on the sides and 3 are based on the angles. To review, the 3 kinds of angles based on the sides are the following. 1. Equilateral triangle. 2. Isosceles triangle. And 3. Scalene triangle. Based on their angles, if one of the angle is measuring an acute angle or angle less than 90 degrees but greater than 0 degree, it's called acute triangle. If the triangle has a 90 degrees angle or a right angle, it's called right triangle. And if one of the angle is measuring more than 90 degrees but less than 180 degrees, we call that triangle as the obtuse triangle. So once again, please refer to your textbook and workbook in order to remember the 6 classifications of triangle. Today, just like what I said, our lesson is all about the interior angles of a triangle. Please refer to your textbook, which is on page 128. You can see that the sum of the interior angles is always equal to 180 degrees. So for example, this angle plus this angle and this angle, the sum of the interior angle is equal to 180 degrees. So today, our activity is all about how to prove this theorem, that the sum of the interior angles of a triangle is always equal to 180 degrees.
Today I'm going to be showing you how you can physically see how the sum of the interior angles of a triangle do in fact add up to 180 degrees. To do that, I've taken some pieces of colored paper and I've cut them into some various triangles. I have an equilateral triangle, an obtuse triangle, and an acute triangle. Let me first show you with the equilateral triangle. So what you need to do is to draw a triangle on a piece of paper, cut it out, and label the angles A, B, and C. You don't have to make an equilateral triangle. It could be obtuse or acute. Just use your creativity. What you're going to then do is to then cut out each angle. Using a straight edge, I drew a straight line on this piece of paper. If in fact the interior angles of this triangle add up to be 180 degrees, then I should be able to fit them together like a jigsaw puzzle using this line as a boundary. So let's take angle A and put it up against the line. Let's take angle B, put it next to angle A, and then angle C should fit in right next to it. And in fact it does. So as you can see, that this is 180 degrees, because remember a full circle would be 360, so this is half, which is just 180 degrees. Now, this isn't a proof in and of itself, because we just did it one time, and it was an equilateral triangle. Now, I want you to take a piece of paper and cut out a triangle. It can be obtuse, it can be acute, make it as weird as you want to make it, and I want you to see if this rule still applies. I'm going to do mine with this acute and this obtuse triangle. I want you to pause the video and try that on your own. As you can see with both the obtuse and the acute triangles, when I fit their angles together like a jigsaw puzzle, they all fit together, showing that again for these triangles, that the sum of the interior angles is indeed 180 degrees. And I'm certain for any triangle that you drew with a straight edge and cut out, this would happen every single time because the sum of the interior angles of a triangle is 180 degrees. I hope seeing it physically helped you understand this theorem a little bit more.
So now, my dear grade 6 students, it's your turn to prove that the sum of the interior angles is always equal to 180 degrees. You need Anuband pad paper, a pair of scissors, and glue. After you draw, you are going to cut it out, and then you are going to paste on the pad paper, showing me that the sum of the interior angles of a triangle is equal to 180 degrees, just like what you saw on the previous video. So, this is Teacher Christopher, and I want to see your work once you get to school. Thank you for learning with Teacher Chris online, and always be safe, my dear students. See you soon.